Hi class, how are you today? Alright, the learning target for today is to understand which parts of a triangle make the different centers of a triangle, and to use the properties of those centers to find unknown parts of a triangle. Alright, so to start off, the four parts of a triangle we're going to talk about today are the angle bisector, the median, the perpendicular bisector, and the altitude. We've talked about these a few times during class, and now we're really going to get real definitions of them. Alright, so the angle bisector is if you draw a line from the vertex of a triangle, it will cut the angle into two equal parts. And I marked that with the red curve on both sides of the blue line. And if you draw all three of the angle bisectors, we get what's known as the incenter. So this point right here, that's the intersection of all three angle bisectors, is known as the incenter. The median is the line from a vertex that cuts the opposite side into two equal parts. So notice with the two lines I marked, those are marking that both of those sides are equal to each other. And if we draw all three medians, we get what's known as the centroid. So again, this middle part right here, this point is known as the centroid. The perpendicular bisector of a side is a line that doesn't necessarily come from a vertex, but cuts a side into two equal parts and it makes a right angle. So if we were to draw all three perpendicular bisectors, we would get what's known as the circumcenter. And finally, an altitude is if you draw a line from a vertex down to the opposite side, it will intersect the opposite side at a 90-degree angle. The altitude is usually used to find the height of a triangle. And if you were to draw all three altitudes, you would get what's known as the orthocenter. Alright, so just as a recap, angle bisectors make an incenter, the medians make a centroid, the perpendicular bisectors make a circumcenter, and the altitude make an orthocenter. In most triangles, these are usually all different points, except in an equilateral triangle where all of these points would be the same, but that's the only case. Now we're going to talk about some properties of these. So with the incenter, if you were to draw three perpendicular lines all coming out of the incenter, and we'll call these G, H, and I, if we have those, then all three of those lines are equal to each other. So let's call our center J, and that means we would have line segment GJ is congruent to line segment HJ, which is congruent to line segment IJ. Something similar works with the circumcenter. So if you have three lines all coming from the vertex and intersecting at the circumcenter, and again we'll just call our center J, then all three of those lines are congruent. So that means AJ is congruent to BJ is congruent to CJ. Alright, so the last one I want to talk about is the centroid. I'm not talking about the orthocenter because there's not any special properties about it, at least none that I want to talk about. So I'll move this over so we can get a little bit more room. So the centroid is a little bit different than the other two that we talked about. The centroid actually talks about the measures of the medians. So again, let's just call our center J. And the rule is that the part of the line segment that goes from the vertex and then stops at the centroid is equal to 2/3 of the whole thing. So that means line segment AJ is equal to 2/3 of line segment AE. So AE is the whole thing, and AJ is 2/3 of the whole thing. So you go 2/3 of the way to the opposite side to get from the vertex to the centroid. And it works the same exact way with the other two. So line segment BJ is equal to 2/3 line segment BF. And line segment CJ is equal to 2/3 of line segment CD. And that also allows you to find some other measures. If the part going from the vertex to the centroid is 2/3 of the whole thing, that means that the line segment that goes from the centroid to the opposite side is then the difference, 1/3. So that allows you to get that line segment JE is 1/3 of the whole thing, AE. And that works for the other two as well. Line segment JF is equal to 1/3 line segment BF. And line segment JD is equal to 1/3 line segment CD. Now that we know those two things, well, we can conclude one more thing. If AJ is 2/3 of the whole thing, and JE is 1/3 of the whole thing, well, 2/3 is twice 1/3, right? So that means AJ is twice JE. So it's double the length. So we can also tell that line segment AJ is 2 times line segment JE. And line segment BJ is 2 times line segment JF. And line segment CJ is 2 times line segment JD. Make sure you have all these rules written down. They will be very helpful in the future. Please take notes on the entire thing, and I will see you next class. Have a good night.